So we were discussing regarding critical path method. So if you remember critical path method, we discussed that this is a kind of technique which tells you which activities are important and which activities can be delayed without delaying the project timeline. So we have a total float. You will see that it being used. It is the amount of time an activity can be delayed without delaying the project as a whole. Free float FM is the amount of time an activity can be delayed without delaying its successor dependent activity. So it's dependent activities if, for example, uh, like SRS for coding, you have SRS as a dependent activity. So what is the amount of time that it can be delayed without delaying its dependent activity? So we'll use early start, early finish, late start, late finish, and these are used basically to calculate the project duration, slack time, and critical path. So there will be two passes. One will be forward pass and one will be backward pass. Forward pass, early start time. You can say you can start with one, and early finish will be the start time plus the duration minus 1. 1 we, if you want, if you start with 0, you don't need to do this minus 1. If you start with 1, you can do this minus 1. Early start of next activity will be equivalent to early finish of the previous activity plus 1, and early finish of the next activity will be early start plus duration minus 1. So it's just like you are starting an activity at day 1 and its duration is 10. So what will be its finish time? 1 plus 10, so that will become 11. And when will the activity 2 start? It will start on 12th day, and for example, if duration is 8 days, so 12 plus 8 will be 20. Backward pass, you will have late finish, late start, late finish. Late finish will be equivalent to early finish of the last activity, and similarly late start can be late finish minus duration plus 1. Late finish of the previous activity will be late start minus 1 of the previous activity. So this is kind of, you can say, this is basically a backward pass in which you will be determining the activities that can end at the end. So you have to start the activity, previous activity, from the end time. You have to focus on this. We'll be doing an example, so it will become more clearer in that. So for example, if we have this, we have these activities, these are the duration, this is precedence. Why precedence is important? Because you will know that which activity will come next. So we have, for example, A, which is starting at 6. We have B, which is the start time at 8, and we have C, which has the start time the duration total activity is 5. So if you see here, A activity has duration 6, B has 8, C has 5. So they all are starting at one point. Why? Because there is no precedence of, or no precedent activity of this. Then G, F and G are dependent on A. So if you see in the previous example, F and G are both dependent on A. So when can F start? F can start when A finishes. So similarly, F has duration 15. So this is kind of a network chart or a timeline where you can see how the activities are processing and which are the dependent activities. So for example, we start activity A at 0 timeline, we start activity B at 0 timeline, and we start activity C at 0 timeline. So this first box is kind of representing early start. So these all are starting at 0 timeline. The duration of A is 6. So 0 plus 6 becomes 9. So when can F start? F can start as early as, 0 plus 6. So it becomes 6. So the F can start as early as 6 units. D can start, which is dependent on B, as early as 8. E can start as early as 5. Why? Because if you see, F is dependent on A, D is dependent on B, and E is dependent on C. So these are their durations. So this is basically early start time. And if you remember the formula, you have to add early start time plus duration. So if we are choosing 1, so we can use the minus 1 thing. If you are not choosing 1, you can simply say 0 plus 6. So this becomes the early start of this. 0 plus 8, this becomes the early start of this. 0 plus 5, so this becomes the early start of the this activity. So similarly, G, it is also dependent on A, so 0 plus 6, so the early start time is 6. Now F, the total timeline of F is 15. So we have the start time 6, we'll add 15, so this becomes 21. So this is basically 21. Similarly, if we move forward, 21 plus 9, so it becomes 30. Similarly, if we go forward here, I 6 plus 17, so this becomes 23, and 23 becomes the start time of I. Similarly, if we have here for looking at D, we have 8 plus 13, which is equals to 21. And similarly for E, 5 plus 9, 14. So we have here 14, and we have here 21. So this activity J is dependent on D and E. D is finishing on 21, E is finishing on 14. So we'll be using 21 because it is dependent on both the activity. Whenever both the activities will finish, so then J will start. So then we can use J here. So J becomes 12, so it becomes 33. So this is basically the forward pass. Going back to the backward pass, so if you see this end, this last time, we have the start time, ending time of 33, 33, and 33. So for example, we have here, this is going to give you 30, this is going to give you 29, and this is going to give you 33. So the highest of this will become the end time of all activity, that is 33. So you will assign this 33 to all the previous one. So for example, 33 will be assigned here, 33 will be assigned here, 33 will be assigned here. So now what was the duration of H? It was 9. So 33 minus 9, it becomes 24. So if you look at the difference, we can start the activity H on 21st day, or we can start the activity H on 24th day. It won't get delayed. So this is basically the critical path method, which tells you which activity will be important, which activity won't be important. So for example, if you look at here, we have here 23 and 27, so they both are different. So you can have slack time of 4. You can delay the activities for 4 days. You can delay the activities 3 days. If you look at this one, there is no slack time. So it means this is important. And if you have to identify the critical activities, these will be the activities that have zero slack time. All the zero slack time activities will become critical path. So this is our critical path here. So this becomes our critical path. Means these are the activities which you cannot delete. So this is our critical path B, D, J. These are our critical path activities which you cannot delay because they are the important or critical activities. So I will do one of the examples, or I will give one of the examples in class as well, so that you can, so that it becomes more clearer.